Hello everyone, my name is Jesus Alberto Casillas, and this is the research topic I'm working on, the joint inversion of physical and chemical state variable data with ASO framework. This work is being in collaboration done between University of Ghent, UNDRAF, and the SCK Institute. So a little bit on framework, so nuclear research or nuclear applications on any type, it can be aerospace, pharmaceuticals, energy production, for instance, produce radioactive waste, right? So what can we do with this type of waste? So this research sits on the framework of the Belgian Nuclear Research Program, so disposal of radioactive waste, which is coordinated by NIRAS on potential disposal systems. Some background information on the groundwater models. Groundwater levels are typically used to constrain these models, but the content of information is very limited, so they cannot capture the complexity of the system, right? Traditional methods only use typically this type of data. However, the implementation of unconventional is suggested by several studies currently, but the application is very challenging because it's very underrepresented in general practice. So the idea for us is to use additional state variables observations to improve the understanding of these systems. The objective is to assess the additional state variables, to constrain the model parameters, because we want to reduce the uncertainty of the model outcomes in respect to only using the conventional state variables, right? So we want to analyze the use of the conventional one, to demonstrate the process understanding by implementing unconventional ones, to evaluate the content of this information, and to identify the potential use optimal of this new observation type. So one application that we have is the performance assessment of a geological repository for nuclear waste, right? Because we want to reduce uncertainty of flow and transport model parameters, because it can aid us in the performance, safety, and feasibility of any geological formations, a host rock, as example, the bone clay. So in our case, we have several numerical models. We have the flow model, heat transport, H tracers, etc. So we want to evaluate each of them individually so we can understand how they bring us more information on the system. Later on, we evaluate them together and we can come up with the more optimal way of using them, right? So if you'd like to know more about this and other research, don't forget to tune in on the November 13th for the day of the PhDs on SCK CEN online. Thank you.